In section 6.6, we're going to look at log equations. Let's back up and point just a little bit. Okay, that's called an exponential equation. Now, since logarithms are exponents, you can get the idea of why they're related. If you can get the same base, and then it's easier to work. So in this particular case, 2 to the third power is 8, and 2 to the fourth power is 16. You raise the power to a power, you multiply. So this is going to give me 2 to the 4x minus 8. Now look, you have the same base, and we made us a law. If the bases are equal, then that means that the two powers have to be equal. Well, that makes it convenient because we can solve. We're going to bring that 8 over to this side, and we bring all the x's over to the other side. So this gives us a nice little answer of x is equal to 8. So I'm going to repeat. If you can get the same base, then the easiest way to work it is to do that. When you can't get the same base, you're going to have to use logarithms, and we're going to see later on how to do one of those. All right, let's start off slow and easy. Let's say that I got the logarithm of x plus 4 to the base 2. And that's equal to the logarithm of 14 to the base 2. Well, we're going to use the same idea. Both of these are the same bases, and the two logarithms are equal. So that means that we can make our equation out of the two numbers. Now, this is a linear equation. You bring the 4 over, and you get a nice little answer of 10. So if we can get the same base, if the two logs are equal, then the two numbers have to be equal. Okay, let's kick it up just a little bit. Now, a crucial part of this problem, you don't have any base given, but we've already said that when you have log without a given base, the base is understood to be 10. So I'm going to put that base down because we're going to have to use it. Now, these two logarithms are added, which means that the two numbers have to be multiplied. Now, I want to review that fact one more time. The logarithm of a number to a base is a power. It means that the number is the base raised to the power. So in this particular case, the x times the x plus 9 is a number. The base is 10 and the power is 1. Now, all of a sudden, look what you've got. You got x squared plus 9x is 10. This is a problem that we did at the second day because this is a quadratic equation. So it is x squared plus 9x minus 10 is 0. We're always going to design these so that they're factored. We don't want any wild numbers with this. The factors are 10 and 1. The plus says the plus has to be the 10. This has to be minus. So this says we get two answers. X is minus 2 and x is 1. Now, this is something that I didn't say the other day that needs saying. You can't take the logarithm of a negative number. Now, the log can come out negative because that means the power can come out negative. So that means this one is no good. This is the only one that works that problem. Now, let's check ourselves just to make sure. We got an answer of 1. So the logarithm of 1 to the base 10 plus the logarithm of 1 plus 9 to the base 10 is 1. Well, the logarithm of 1 to any base is 0. The logarithm of 10 to the base 10 is 1, and 0 plus 1 is equal to 1. Very important. Most of these you're going to come out with this situation that one of your answers is going to be negative, the other answer is positive. You can't take the logarithm of the negative number. Now, we can kick it up just a little bit. Suppose that we got the logarithm of x plus the logarithm of x minus 15 is equal to 2. Well, once more, the base understood is 10. So the two logarithms were added, which means that the two numbers are multiplied. So this says that my number, which is this product, whatever it is equal to the base, which is 10 to the second power. So this gives me x squared minus 15x is equal to 100. So I got x squared minus 15x minus 100 is 0. All right, let's try to factor this thing. This factors 20 times 5 is 100. And the negative goes with the biggest positive be here. So I get two answers. X is 20 and x is minus 5. Once more, we can't use that minus 5. X is equal to 20. The answer to that problem. Okay, 7 to the 3x minus 7 is equal to 49. Now, you could work this with logarithm, but I don't recommend it because of this simple fact. Look at 49. It is equal to 7 squared. Well, that makes it real convenient. The two bases are equal. So we just make our equation out of the power. So this says that 3x is equal to 7. So x is 7/3. If you can get the same base, that is your best way to work these problems. If I got the logarithm of 11x to the base 4 is equal to 2. So I got 11 times x is equal to 4 squared. So this says that x is going to be 16 divided by 11. Yeah. You got 6 to the x is equal to 9. In fact, I'm pretty sure you have one like this on test. You have one like it on the quiz and on the homework. The problem with this one is I can't get the same base. If you can't get the same base, then you have to use logarithm. So the logarithm of the left side is equal to the logarithm of the right side. And this is a power. So this is going to be x times the log of 6 is equal to the log of 9. So x is the log of 9 divided by the log of 6. And you can do this straight out on your calculator. Just look up the log of 9 divided by the log of 6, and it will give you a decimal value. Let's just see what we've got here. We've got a little time on the calculator here. You have to be careful when you put this into your calculator. You put the whole top in parentheses and you put the whole bottom in parentheses.